Hello, this is Yo-Yo. So today we're going to talk about modeling with linear function. First of all, I want to introduce the 5-step problem-solving process. So step 1, identify the problem. Oops, sorry. Step 2 is to gather the information. Step 3 is create the equation that we need to solve the problem. Step 4, we're going to solve the equation. Step 5, you're going to verify your answer. Such as finding the right appropriate unit and write down your conclusion in a complete sentences. Okay, here I'm going to give you an example how we are going to use the 5-step process to solve the real-world problem. So here's the example. A company purchased $120,000 in new office equipment, then expected the value to depreciate by $16,000 per year. Find the linear model for the value. Then find and interpret the horizontal intercept and determine the reasonable domain and the range for this function. Okay, now take a pause and think about, if you were me, how we are going to solve this problem within our 5-step process. Okay, so the first step is we want to identify the problem. So what do they ask you for? So first step, identify the problem. What do they want you to do? They want you to what? Find the linear model. For the value, and then interpret the horizontal and the horizontal intercept and determine the reasonable domain and the range for the function. So we also want to find the horizontal intercept and the domain and the range. So now, second step, we gather the information that we have. So when the company purchased the new office equipment, it spent $120,000. So at beginning, at year 0, the spending what? $120K for in the new equipment, and then the value depreciate every year. So that means the value. So after first year, how much does the equipment worth it? Well, you're starting from $120,000 and then you depreciate $16,000 each year, right? And then what about second year? Second year is what? You use the initial value and subtract. So since it's second year, so that means it's going to depreciate 2 times of 16,000. And then we continue on third year, the office equipment worth what? $120,000 subtract 16,000 times 3 years, because you have been using it for 3 years. So now after n years, how much does this worth it? This is going to worth what? 16,000 times n years. So here is the linear model that we found. So the equation that we have is the value of the office equipment worth it. Let's use fx for the value of the office equipment and n for the number of years that you use the equipment. Okay, so the equation is going to be what? Fx equals to 120,000 minus 16 to the n. Oh, I got this wrong. Here I should write down n. Okay. So the fourth step is trying to solve the problem. So in this case, we need to solve what? So they ask you to find the horizontal intercept and domain and the range. So horizontal intercept is what? Horizontal intercept is when you have a random, I'm just going to draw a random linear equation like that. So your horizontal intercept is x-intercept. We also call it x-intercept. And what do they have in common for all of the x-intercept? When y equals to 0, right? So now let's let y equals to 0. In our case, it's going to be f of n equals to 0. When f of n equals 0, so that means the equation equals to 0. We're trying to solve for n. So n is equal to 7.5. So now how do we interpret it? What's that mean? When n equals to 7.5, f of n equals to 0. What does that mean when you try to interpret it? Remember, n means the number of the years that you've been using the office equipment. F of n means the value of the office equipment. So the x-intercept or horizontal intercept stands for what? After 7.5 years of usage of that new equipment, the office equipment worth $0. It worth nothing. Okay, so now what is the range? And what is the domain? Sorry about that. So what is the range? Range is all the possible value of the output. Domain is all the possible value of the input. So now let's look at the range first. So range in here, what is our output? Our output is our f of n, which means the value of the equipment. So at beginning, the equipment worth 120,000, right? So you can only go down, right? There's no way after you use it, the value will increase. Use common sense. Like in reality, think about that. It only makes sense the value decrease. So how much they can decrease? They can decrease to a negative amount of money, right? So that means the range has to be from $0 to the highest, which is when you first purchase 120K. So what about domain? We know that the domain after 7.5 years of usage, the equipment worth 0. So that means the highest time, the longest time you can use the equipment is 7.5 years. And when you first buy it, it's just starting from 0. You can start it from 7.5. Okay, the first step is to verify your answer. So you need to check, okay, does this make sense? If somehow you think the domain is negative infinity, which makes no sense, you can use negative years of the equipment, right? So you double check it and you find out that, okay, this is correct. We're starting from 0 to 7.5 and the range is from 0 to 120,000. So yeah. Now let me show you another examples. So here's a second example. So Jamal is choosing between two moving complaints. The first is U-Haul, charges an upfront fee of $20, then 15.5 per mile. The second is Budget, charges an upfront fee of $16 and then 16.3 in a mile. So when will U-Haul be better choice for Jamal? Okay. So now let's take a look at this question. So we encountered that a lot when we choosing some sort of services, they have different charges, and then you need to know which one is better for you. So for U-Haul, well, the easy way is we can set up an equation and think about, okay, like which one would be cheaper for me overall, because you need to give them the mileage that you move in, right? If you're moving from Boston to Chicago, of course, I would say U-Haul is not Chicago. If I'm moving from Chicago to Seattle, probably U-Haul is better. But if we're moving within the city, Olympia to Olympia, then probably Budget. So which is the break-even point? Okay, so now let's set up the question. So for U-Haul, what will be the charges? Well, U-Haul, I'm going to use, first of all, let X be the distance in miles that Jamal is moving. So what would be the cost if he decided to use U-Haul? So the cost should be what? U of X equals to the upfront fee, $20, plus what? 59 cents per mile. So it should be 59.59 times X, right? That's the function for U-Haul. And then we will have a second function for the Budget complaint. So the function about Budget is what? So the upfront fee is $16, and then 63 cents per miles. So here's really important. Some of you need to bear in mind that, hey, what unit you have been using. So since we're using dollars as for unit, so you might see, okay, 15.5 cents, I'm going to write 59. So this is wrong because remember our unit is dollar, so that's why you want it to write in the form of 0.59. Okay, so now we have the cost of these two components. So how do we know which one is a better choice for you more? Well, if we want U-Haul is better choice, that means U-Haul, the cost of U-Haul is lower than the cost of Budget, right? Then we can say, okay, U-Haul is better. So how do we know when it's going to be lower? So now we have these two functions, right? 20x plus 5.9 and then 16 plus 0.163x. Well, since the cost of U-Haul is 20 plus 0.59x, we want it to be lower than Budget, so which means less than the cost of Budget. So the setup should be here. Okay, so now let's solve for x. You subtract 16 on both sides. So you have 4 plus 0.59x less than 0.63x. And then you minus 0.59x on both sides. So I have a 4 less than 0.04x. And then you divide it by 0.04 on both sides. So I should have 100 less than x. What's that mean? So that means if the most moving distance is greater than 100 miles, he should choose U-Haul. U-Haul is a better choice for him. So done. So in the future, if you encounter some problem like that, you can just list a function like how we solve it in the math class. Apply this knowledge in your real life. It will help you a lot. Okay. So for the next really common application problem that we can have is the cost, revenue, and the profit in the field of cost, revenue, and profit. So when the company produce like X items, the total cost is the cost of the total cost of producing those items. The total cost including both fixed costs, which is the start cost, or like what the previous example that we have, the fixed cost for Jamal is going to be $20 to using U-Haul, right? And then there's a variable cost, which is each mile the U-Haul is going to charge him 59 cents. And then the total cost, let me write this down. So the total cost is going to equals to the fixed cost plus the variable cost. Okay, revenue. So what is revenue? Revenue is the amount of money a company brings in from the sales. And the profit is the amount of money brings in after the expense. So that means the profit equals to the revenue minus the cost. That has a lot of application in the business world, right? Such as when you go to the mall, you buy a coat. The coat costs $100, right? But this is not the profit for the company, because in this $100 you need to pay for the labor fee, the material, advertisement, the rent that you use for the store, right? Lots of things. So you need to subtract all of these costs, and then you will find the profit of the clothes. Maybe the profit would be $20 or $50. I don't know. But cost and the profit are different. So, the profit and revenue is different. So revenue, remember that, is how much you're going to sell the item, such as for this clothes, $100. So your revenue is $100. And then you subtract the cost maybe is $60. So your profit of this outfit is going to be $14. Okay, so there is a break-even point. So what is break-even point? So it's the level of production where the revenue equals to the cost. That is the break-even. So which means the profit equals to 0. This is typically the minimum level of sales necessary for the company who makes the profit. Okay, so now let me show you examples. So a tech startup looking at developing and launching a new mobile apps. Initial development of the app will cost $300,000, and they estimate the marketing and the support for each user will cost 50 cents. While the app will be free, they estimate they will be able to bring $2 per use on average from in-app purchase. how many users will the company need to break even? Well, so the break even, remember that break even is when revenue equals to the cost. So now let's take a look. What would be the revenue for the company? If we let N be the number of the user of the apps, or people that download the app. Okay, so the cost, let's take a look. What would be the cost? The upfront cost to development about the app is 300,000, and then that's the fixed cost. Remember, cost has two parts. Plus the variable cost. The variable cost will be 50 cents per user. So that means we need to add 15 cents times N, which is per user. So now we want these to break even. So break even means equals to the revenue. So now let's look at them. They estimate they will be able to bring in $2 per user on average from in-app purchase. So that means $2. You're going to make $2. Your revenue is going to be $2 per user. So the total revenue is going to be 2 times N. So now we can calculate, we can solve N to calculate the break-even point. Okay, so we're going to add subtract 50.5 N on both sides. So we have 300,000 equals to 1.5 N, and then divided by 1.5 N. So N is equals to, let me check, N is equals to 200,000. So that means this tech company is going to break even when there are 200,000 of users. So you need to write it down to verify your answer. So the another application in the business field is supply and demand. This is really typical. So in economics, there is a model for how prices are determined in free market, which states that supply and demand for the product is related to the price. The demand relationship shows the quantity of a certain product that consumers are willing to buy at a certain price. Typically, the quantity demanded will decrease for an item if the price increases. The supply relationship shows the quantity of the product that suppliers are willing to produce at certain sales price. Typically, the supply and demand will increase if the price increases. Economic theory says that the supply and demand will interact, and the interaction will be equilibrium prices or market price, where the quantity supplies and the demanded will be equal. Okay. So now let's take a look at this example. So at the price of $2.50 per gallon, there is a demand in a certain town for 42.5 thousand gallons of gas and a supply of 20,000 gallons. At a price of $3.50, there is a demand for 25.5 thousand gallons and a supply of 28,000 gallons. Assuming the supply and demand are linear, find the equilibrium price and quantity. So basically, you're trying to find their intersection. Each supply and demand are two different linear equations. So the first step is you want to find the linear equation first. So for supply, we have what? If the price is $2.50, so the corresponding supply is going to be what? 20 gallons, right? And then if the sales price is $3.50, and then the supply is going to be 28,000 gallons in gallons. So now let's find out what is the relationship given this order pair. So the first step is we can find the slope. So the slope is equals to 20 minus 28 over 2.5 minus 3.5. So I have 8 divided by 1, which is 8. And then we need to find the equation by substituting one of the numbers in it. So let's say the supply, I'm going to use S with a function of X. X is like how many gallon or the price. S represent the price that you're going to sell per gallon. So I have what? 8 times X plus B. So the supply function is going to be what? I substitute the first order pair into the function. I have 20 equals to 8 times 2.5 plus B. 8 times 2.5 equals to 20. So B equals to 0. So that means the supply equation is going to be what? X equals to 8 times X plus B, which is 0. So we can leave them there. And now we also need to find the demand. So the demand equals to what? If at the price of $2.50, the demand is going to be 42.5 thousand gallons, and then if the price is $3.50, the demand is going to be 25.5 thousand gallon. Okay, so we use the same method to find the slope. Since this is a linear, the relationship is linear. So the slope M is equals to 42.5 subtract 23.5 over 250 minus 350. So I have 17 divided by 1, negative 1. So it should be negative 17. So I will have the demand function. Demand function is equals to negative 17x plus b. And now we need to substitute this into the equation to find out our b. I have 42.5 equals to negative 17 times 2.5 plus b. And you solve it. B is equals to 85. So the equation, the demand equation is equals to dx equals to negative 17x plus 85. So now we have these two equations, the supply equation and the demand equation. So from a linear function, on the graph, you should see something like that. So the demand, the supply maybe look like this one. This is our supply, which is equals to AX. Okay, and demand function, I'm going to use negative 17 plus 85, something like that. I'm going to use different color of pen. So when is the equilibrium price or equilibrium quantity? So remember the x-axis represent what? The x-axis represent the price, which is our x, and the y-axis represent the quantity, how many in gallon, right? So the equilibrium means their intersection point in here. So how do we find the intersection point? In our previous in our previous video, we talked about the intersection is when the y and x are equal to each other. So that means when the supply equals to the demand, we will find our equilibrium prices. Okay, so now the supply is equal to AX and the demand is equal to what? Negative 17x plus 85. Now we solve for x. So we add 17 on both sides. So I have 25x equals to 85. Yeah. And then we divide it by 25. So we have what? X equals to 3.4. So that means this point, when x equals to 3.4, which means x is $3.14, we will have our equilibrium prices, but we still need to find quantity. Well, you can substitute x equals to 3.4 into the supply equation or into the demand equation. They should be equal because there's an intersection point. That means the y here should be equal. So okay, I'm going to substitute that into the supply one. So 3.4 times 8 equals to 27.2. So that's it. So I'm going to recap this. So equilibrium prices and quantity basically is you're trying to find the intersection of these two linear equations. So now let's try another example in here. A company estimates that at the price of $114, there will be demand for 4,000 items, and for each $5 increase in prices, the demand is going to drop by 200 items. The supply curve is P equals to 1/20Q, and find the equilibrium prices and the quantity. Okay. So Q usually stands for, P stands for the prices, and Q is the quantity of the item that they want to produce. So in a coordinate plane, we have what? P in here, Q in here. So for supply, the curve is this one. This is our supply. P equals to 1/2 Q. Oh, I'm sorry. This is Q, quantity. And this is the price. Okay, so now we still need to find the demand. We haven't figured out the demand yet. So remember, the order pair changed now. In our previous example, I used what? X represent the price, and then Y represent the quantity. But in here, it switch. Quantity is the X, and then price is the Y coordinate, but they are the same. So now let's look at demand. Demand is what? The quantity of the demand, the price of the demand, is related to the quantity. So the price equals to, let me use different color pen so you know that these represent the demand. So P, price, equals to what? So if the price is $14, you will have 4,000 items. And then they say for each $5 decreases in prices, the demand will drop by 200 items. So that means the second order pair would be what? If the price increased $5, if your price is $145, and then the demand is going to drop by 200 items. So the demand is going to be what? 3 13,800. So these are the two order pair that you will find. It's a little bit tricky, but it's doable. Okay, so after we find this order pair, now we need to find the slope. The slope is equal to what? Changing in y over the changing in x. So this is equal to 5 over 200, negative 200. So should be negative 140. Should be negative 1 over 40. Okay, after we find m, we still need to find our b. So I have what? The price equals to negative 140 times the quantity equals plus b. We can substitute one of these order pair in here, right? I'm going to substitute the first one. So when the price equals to 140, and then the quantity is going to be 4,000 plus b. B is equals to 240. You can solve it by yourself. So now we have our linear equation for the demand, which is the price equals to negative 140 plus 240. Okay, so if we draw it, it's going to look like something like that. So this is our demand function. The price equals to negative 140 plus 140Q plus 240. So now the equilibrium price and quantity is going to be the interception, right? So the interception is what? When the P equals to P and Q equals to Q. So to find the equilibrium prices and the quantity, we let the supply equals to the demand. So the supply is equal to what? Supply is equal to 1/20th Q equals to negative, oh, I forgot the Q here, negative 140Q plus 240. And then we solve for Q by adding 114 on both sides, 114Q on both sides. And then this is equal to 314Q equals to 240. So how do we get rid of the fraction? So to get rid of fraction, what you can do is multiply the reciprocal on both sides. So look, this you can cross cancel, which is very nice. And this one, cross cancel 80. So Q is equal to 13,200. Okay, that is our equilibrium quantity. So we still need to find the price. So the price equals what? You can substitute these into either the supply function or the demand function, either one. I will use the supply because it's easier. They don't have to deal with the B. So the price equals to 1/20th times Q, which is 32,000. So our P is equal to what? 160. So now we still need to verify our answer by write down a complete sentences. So the equilibrium price is 160 and the equilibrium quantity is 13,200. Don't forget to write down the conclusion. Okay, so that's it for today's classes. Let me know if you have other questions.